And so a radical expression is an expression that contains that square root symbol. A radicand, the radicand is an expression under the radical. So the number, the expression, the variables under the radical are the radicands. All right, guys? And so today we're going to be talking about how we can simplify radicals. And guys, there's going to be some important things that we'll discuss. We're going to talk about our perfect squares and some other fun things. But guys, when you simplify radical expressions, there's a few rules that we will need to follow. Okay? So simplifying radical expressions, there's a few rules. The first rule is that the radicand, the number under the radical, has no perfect square factors other than 1. So guys, a radicand has no perfect square factors other than 1. Number 2, the radicand, the thing under the radical, has no fractions. Okay. And last but not least, the denominator does not contain a square root, does not contain radicals. So there are no radicals that are allowed in the denominator. So those are a few of our rules. And if all of those things are met, then my radical is fully simplified. Okay? And guys, sometimes your radical can be simplified to a whole number. If it's a perfect square, it can be simplified to a whole number. And there's a couple properties with radicals that we are going to talk about. We have the product property, where basically, guys, if you have A times B under the radical, or if A times B is the radicand and they're under that radical, you can separate them into radical A times radical B. You can separate them out. Okay? And the quotient property is very similar to our product property here. And guys, if you have a fraction under your radical, you can write it as 2 separate radicals. So you can say radical A over B is equal to radical A over radical B. Okay? So that will help us when we simplify. So guys, these are all kind of important rules and then little helps here. Now guys, something that is going to be very, very helpful for you guys is to know your perfect squares. All right? And my recommendation is to know them up through 15. Now guys, my perfect squares, I want you guys to think about these, all right? So guys, your perfect squares are the numbers that if you take the square root of it, it simplifies to a whole number. Okay? So guys, when we are taking the square root of something, what are we, okay, so let's write out our perfect square. So I have some of them listed over here on the side wall. But guys, 1 is a perfect square because the square root of 1 is 1. Perfect. All right. 4 is a perfect square because the square root of 4 is 2. Does this make sense, guys? And then so on. 9 is a perfect square because the square root of 9 is 3. All right? So if you wanted to do this the opposite way, so as we're going up here, 1 times 1 gives us 1. 2 times 2 gives us 4. 3 times 3 gives us 9. You can also write it as 1 squared, 2 squared, or 3 squared, right? So guys, basically, when you take the square root of something, you are asking yourself what 2 numbers can multiply together to give me my number, okay? So my perfect squares, I'm going to go ahead and give you this lovely little list here. After 9, it is going to be 16, because 4 times 4, or 4 squared, is 16. And then after 16, it's going to be 25. After 25, it's going to be 36. After 36, and so guys, here's the deal. This is going to be, oh, what am I doing? All right, there we go. It's going to be 49. And guys, here's the deal. This is something that I want you guys to know off the top of your head. The reason I'm typing these in the calculator right now is so that you guys can see where I'm getting these numbers from. Okay, I see 81, 100, 121, 144, 169, 196, and 225. So y'all, these right here are my perfect squares, numbers 1 through 15. And guys, if you want to think about what the square root of those are, you can also say that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, guys? So those are the perfect squares for numbers 1 through 15. And guys, if you notice over on the side right there, the reason why they're called perfect squares is because if each side length of a shape is 7 and 7, then there would be 49 squares inside that perfect square. So guys, you can kind of see the visual right there over on the side next to the calculators. You can see how like all of those perfect squares have a perfect number of little squares that fit inside the big square. So that's why it's called a perfect square. Yes?
I'm confused. What would you use these squares for?
Exactly what we're doing next. So that's what we're going to talk about. Okay? So I'm giving you the information that you need for the very next problem. So, because you need to know your perfect squares in order to be able to simplify radicals. Because, look back up here. A radicand has no perfect square factors other than 1. So what you have to do is we're going to have to identify factors here. Okay? So here we go, guys. So for an example, when you guys are simplifying radicals, sometimes they are going to simplify to a nice, pretty whole number. So guys, for example, number 1, if I take the square root of 25, well guys, is that a perfect square?
Yes.
So that would give me 5. And if you did that in your calculator, you would go here and say the square root of 25 gives me 5. That's my answer, because it's a nice, pretty whole number. Does that make sense? So knowing your perfect squares is important. Okay, so I'm going to do all nice, pretty, perfect ones right here. Square root of 169. Well, guys, if we look at our little chart here, that is going to be 13. Now, here's the deal. If you don't know your perfect squares, are you totally up a creek? No, because look, if you type in your calculator, does it give you 13? Okay? But I will tell you guys, knowing these readily will be very, very helpful and important. All right? Let's take a look at this one. The square root of 36 over 25. Well, guys, according to our little quotient property rule, we can separate this out into the square root of 36 over the square root of 25. Well, guys, the square root of 36, that's a perfect square. So that becomes 6. Square root of 25 is also a perfect square. So that guy would become 5. And guess what? If you type this in your calculator, the square root of 36 over 25, it's going to spit out 6 over 5. Magic, right? So guys, sometimes when you do these guys, you will see different things. All right, I'm going to do one more for you guys. Now I'm going to write one with a coefficient here. 2 times radical 144, or 2 times the square root of 4, or 144. Well, guys, what's the square root of 144 again? 12. We look at our little chart here. Our square root is 12. But, guys, it's going to be 2 times that 12, right? Because it was 2 times radical 144. So my final answer is actually going to be 24. Does that make sense, y'all? So if it is a perfect square and it simplifies completely and you get a whole number, then you are done. Do y'all feel good about that? Awesome. Okay? So that is one of our little steps right here. All right, so what I'm going to do is I'm going to show you guys some more examples where they are not perfect, because everything is not always perfect in life. Okay? So, are you guys okay?
Yeah, no. We were talking about something that we heard. It wasn't you.
All right, cool. So here we go. So guys, what we are going to do is I'm going to show you guys how to simplify radicals that are not perfect squares. All right? So if they are not perfect, then guys, I'm going to teach you how to simplify radicals that are not perfect. So guys, for example, if we take the square root of 24, that is not a perfect square, right? Because if we plug this in, the square root of 24, it's going to give us that weird looking decimal, 4.898979486. And guys, it's actually an irrational number, so it would continue on for longer and longer. Okay, guys? So those decimals would keep going for a long time, okay? Because it's irrational, okay? Now, here's what's kind of cool, guys. If we took 4.898979486 and I squared it, what should I get?
24.
Should get 24. I don't know if it's going to cooperate because it technically continues on. Oh, it did. Okay, good. So the calculator knew what I was trying to do. That's good. So, guys, if we square that, we get 24. And, guys, here's the deal. You can kind of estimate perfect square values because you're like, okay, it's the perfect square for 5 is 25. The perfect square for 4 is 16. So it's going to be between 4 and 5 because 24 falls between 16 and 25. It's pretty close to 25, so it's going to be a lot closer to 5. So you're like I would have guessed 4.9, but it was 4.89. So that's pretty good. If I had to make a guess, I probably would have said, it's about 4.9. Okay? Because it's pretty close to 25. Okay? However, if we want to simplify radicals so that they are written in simplified radical form, what we have to do is we have to think of a perfect square that is a factor. So guys, going back to our perfect square list here, I'm going to write my perfect squares across the top here. So I'm going to write 1, 4, 9, 16, 25. I'm just going to write all those numbers across the top of so I'm thinking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, yikes, and then I'm going to do 14, 15, 16, ugh. 196 and 225. Guys, how I remember 13 and 14 is like it's 169, and then you flip-flop, then 6 and 9 becomes 96. Just FYI. And then 225. Okay? So guys, do any of these perfect squares or any of these factors of 24? Do any of those multiply to give you 24? Yeah? 4 and what? 4 and 6. So guys, one of those is perfect. So I always put my perfect square first because I can rewrite that as radical 4 times radical 6, right? Radical 4 times radical 6. Well, guys, because of my product property, I can separate those into square root of 4 times the square root of 6. Does this make sense, guys? Or do y'all feel comfortable with 4 times 6 being equal to 24? Okay. So, guys, here's the thing. A factor for 24 has to be under 24, right? So if I wanted to find a perfect square factor, I'd only be looking at 1, 4, 9, and 16. 16 is not. 9 is not. Hey, 4 is. There we go. Ding, ding, ding. Does that make sense, guys? So you can kind of look at those. And if you weren't sure, you could say, okay, 24 divided by 4, well, that gives me 6. So it's 4 and 6. You could kind of see it that way if it gives you a whole number. Well, guys, what's the square root of 4? 2. So the simplified radical is 2 square root of 6. Because that little square root is 6, we can't simplify that, so it just got left behind. Does that make sense, guys? So this right here would have been 2 times the square root of 6. And look at this. This is one way that you can check your answer. Conrad, I want your head up, sir. All right, one way you can check your answer is you can type in your original radical, and you can type in your simplified radical. And guys, do they give you an equivalent decimal? They sure do. Isn't that kind of cool, guys? So so you can always check yourself, because you can say, okay, my original radical and my simplified radical, those are the exact same value. Yes, ma'am? Yes. They're not in her classroom. I am not sure. They might be in one of the other teachers' classrooms for geometry, or they put this son. Did she read any sub-notes? She's not here today. And she probably has sub-notes in front of her. Who do you need me to look for? 28025, yes, I'll do it.
I can't do it. I don't get the correct thing. No, real. I can't structures. I know. Oh, no, I can do it. I start coloring. Then I have to go back and What is that? How did we get to? And then I turn around and 2. Oh, I don't know where it is. Because the square root of 4 is 2. Yeah. How did we get to? The square root of 4 is 2.
All right, guys? All right, let's look at this over here. Okay, guys, so this is my perfect square method right here. All right, let's look at number 2. So, guys, this next one we're going to look at 4 times the square root of 63. So, guys, here's the deal. The first thing I want you to do is look and see, is 63 a perfect square? No. It's pretty close. It's almost 8. So it'd probably be like 7.9-ish. All right? Do y'all feel pretty good about that? Does that make sense? It's almost 8 because 64 is the perfect square for 8, but not quite. And guys, if we do 4 times almost 8-ish, it's going to be somewhere under 32, 31, something like that. So guys, 4 times the square root of 63, there we go, 31. Okay? So 31.749, So guys, one of the first things you can always do is type it in. And if it gives you a whole number, then you're done. And the whole number is your answer. Does that make sense? Or if it gives you a clean fraction, you're done. So guys, we have this, but it's not simplified. So guys, what we are going to do is I'm going to take this lovely little one, and yep, you can come on in. You can come in. There you go. Perfect. All right. So guys, what we are going to do is we are going to separate this out. Are there any perfect squares that will be going into 63? Remember, guys, we have to look at all the perfect squares that are smaller than 63. Okay. Will 49 divide into 63, y'all? No. What about 36? I don't think so. And if you're not sure, guys, you can just sit here and say, okay, 63 divided by 36. No, that's not a whole number. Okay, what about 63 divided by 25? Yikes, I hope we know that's not true. 63 divided by 16. That's not good. Guys, what about 63 divided by 9? Yay. So, guys, what we can do is we can separate this out. Instead of 63, we can say 9 times 7. And, guys, my little hint for you is always put the perfect square first, okay? Because when you simplify, it'll just look cleaner that way. All right, guys? So that's going to be one of my little hint for you here, is always put the perfect square factor first. All right, guys, so always put that perfect square factor first. And, guys, we can write this out as 4 times the square root of 9 times the square root of 7. Now, guys, what is the square root of 9? 3. That's our perfect square. That was the whole point. We wanted to do that lovely little perfect square. We still have our 4, and we still have our square root of 7. So, guys, 4 times 3 is 12. So that becomes 12 square root of 7. And, guys, what I like to do is I like to go in here, and I like to start, and I type in my very first thing, 4 times the square root of 63, and 12 times the square root of 7. Do I get the exact same weird-looking decimal? Yep. Yes. So, guys, so you always want to put the perfect square factor first. And then, guys, you can check the original with the answer by making sure the decimals match. Like, check the original, that 4 times square root of 63, with your answer, 12 times square root of 7, by making sure the decimals match. Okay, do you guys feel pretty good about that? All right, so you type the original radical and the simplified radical to the calculator to make sure the decimals match. All right, so guys, now what I want you guys to do is I want you guys to see, we're going to do number 3 right here. And guys, this one's going to be a little interesting. We're going to say 3 times the square root of 192. Yikes, that's a really big number, isn't it? What? Negative 3. Sorry. Negative 3 times the square root of 192. Sorry, my 3's a little bit loopy there. All right, guys? So, does 192 have any perfect squares that are factors of it? Well, yeah, that's a perfect square. So, 192 is not a perfect square. Because then if we go here and we say 3 times the square root of 192, that does not give us a perfect square. It's close to 196, but it's under that 14. So guys, are there any perfect squares that go into 192? Yes, sir? The square root symbol. Good question. Guys, in your calculator. So guys, squares and square roots undo each other. And guys, a lot of times they're right connected to each other on the calculator. So you guys see if you hit second and then the x squared button, you can pull up your square root symbol. Cool? So guys, when you have this one right here, guys, how would you find the factors for 192? You're going to divide. So what are some good factors? Any of these guys or any of these guys factors for 192? 16. All right, let's try it.
And 64.
Okay. There's 2 of them. And I'm going to show you why that's important. All right. So guys, 16. So Romina guessed 16. It's an even number. That's a good guess. So, and look at that. When she does that, it's 16 and 12. That's awesome. So what we're going to do is we're going to say negative 3. Remember, put your perfect square first, times 16 times 12. And guys, here's the deal. I don't usually rewrite this multiple times. What I do is I kind of circle my perfect square, and I say, what's the square root of 16? 4. So what is the radical that got left behind here?
12.
The square root of 12 there. So we have negative 3 times 4 times the square root of 12. So guys, that gives me negative 12 times the square root of 12. Are you guys good with that? Oops, that was supposed to be in turquoise, I guess, teal. And guys, if we looked at this and we said negative 12 times the square root of 12, are those equivalent decimals? Yes, which is awesome. However, guys, can radical 12 be simplified? Does radical 12 have any perfect square factors? You can divide it by 4. So check this out. We can actually separate radical 12 into 4 and 3. So check this out. If we do 4 and 3, well, guys, what's the square root of 4? 2. So what got left behind? Radical 3. Conrad, please lift up your head, sir. Go get a drink of water, go to the bathroom, do something. Okay? So negative 12 times the square root of 2, what is that going to give us? Negative 24 times the square root of 3. So guys, is this actually my fully simplified radical?
Yes.
Yes, because guys, can square root of 3 be simplified anymore? So here's the thing. Guys, this one right here, you had to keep going. We were not done here, right? Because the square root of 12 can be simplified. So guys, we were not done on this step. Those radicals, those are equivalent to one another. The square root of 12, or negative 12 square root of 12 and negative 24 square root of 3. They're equivalent, but guys, they're only fully simplified if there's no factors that have perfect squares. Y'all tracking that?
Yeah.
Okay. So here's the deal. One thing that David mentioned that was earlier. So guys, you can get the right answer, but does it take you a couple times? Okay. So I'm going to show you guys, David mentioned that the other perfect square factor for 192 was 64. Okay? And guys, what is the square root? And so 64, 192 divided by 64 gives me 3. So I could actually say negative 3 times 64 times 3, right? Putting that perfect square first. Well, guys, what's the square root of 64? It's going to be 8. Very good. And so, guys, what got left behind was this little square root of 3 here. And then we have our negative 3 on the outside. And, guys, what's negative 3 times 8? Negative 24 square root of 3. Guys, which process was faster to do? The 64 one. So, guys, here's the thing. When you are simplifying, my recommendation is make sure you pick the largest perfect square factor. All right? So, guys, the largest perfect square factor. All right? Because, and I feel like this happens the most often with 4s, 16s, and 64s. Because they all can be multiplied to get each other. Does that make sense? So I feel like it happens the most often with my 4s, 16s, and 64s. It also sometimes happens with 9 and 81. Those are, and then 25 and 100. So guys, those are all ones right there. So if you have a really large number, guys, my recommendation when you are trying to find the perfect square factor, start with the larger numbers. So you would be like 192 divided by 144. Nope. 192 divided by, let's try 81. Nope. 192 divided by 64. Hey, that's good. So like start with the bigger perfect squares before you start with the smaller perfect squares. Does that make sense? So that's my recommendation for you guys as you go. Okay? So that one is right here. So guys, we have our perfect squares there. All right. So now what we're going to do is we're going to talk about multiplying radicals. Okay? So guys, this is when you are multiplying radicals. Ooh, I'm saving a page here. Multiplying radicals. So guys, remember that lovely little a times b. Radical a times b is equal to radical a times radical b. Guys, it works in reverse as well. So for example, and so guys, the big 3 steps that you want to know about is, guys, first, we multiply the coefficients. If it's on the outside, multiply it by the outside. And then, guys, you multiply the radicands. Yes, sir? Ooh, no, I want you to hang on. Multiplying the unless it's like, if you're dying, you can definitely go. But multiply coefficients, multiply the radicals, and then, guys, your final step is going to be simplify. So, y'all, on this one, basically multiply the outside by the outside, multiply your inside by your inside, all right? So when I say coefficient, think outside by outside. And then when I say multiply the radicals, think inside by inside. Okay? So we're going to do outside by outside and inside by inside. So I'm going to give you all a couple of examples here. So number 1, we're going to have 5 square root of 2 times the square root of 2. Okay? So guys, if I want to multiply my outside by my outside, the first thing I multiply is my 5 times, well guys, is there anything on the outside over here? What's like kind of the invisible coefficient then, y'all? It's like a 1. So 5 times 1 would give me 5. Are you guys okay with that? And then square root, and then 2 times 2 would give me 4. So that becomes 5 square root times the square root of 4. And so guys, first you multiply outside by outside, inside by inside, and then you simplify. So y'all, what is the square root of 4? 2. So this becomes 5 times 2, which is 10. So y'all, my final answer for that one would have been 10. Now guys, here's the deal. Could I have typed this into my calculator and said 5 times the square root of 2 times the square root of 2? Yes, I could have.
What if it doesn't give you?
What?
What if it doesn't give you like the whole number?
So then you simplify your radical like we did on these top 3 examples. So for example, let's take a look at, this is one that's not going to give you a nice whole number. Okay, Nico? So let's look at this one. 2 square root of 6 times negative 3 square root of 8. Okay? 2 square root of 6 times negative 3 square root of 8. So we're going to do outside by outside. So 2 times negative 3, which gives me negative 6. Inside by inside, 6 times 8 gives me the square root of 48. Now, Nico, you said, what if it doesn't give us a nice whole number? Let's see here. So 2 square root of 6, I forgot to check. Here's the deal, guys. I would always check. Always check first. And that does that give us a nice pretty whole number? No, it does not. It gives us negative 41 something, something, something. So guys, if you type in your calculator, you get a nice pretty whole number. Now, guys, we need to simplify the square root of 48. What can I break that square root of 48 into? What is a good perfect square that goes into 48? What'd you say? Let's look at our perfect squares over there. So you got to think it's got to be less than 48. So, guys, can 36 go into that? No. Okay, let's try it. Will 25 go into it? No. Okay, 48 divided by 16. Hey, that's going to be our number right here. 16 times 3. Guys, I want y'all to notice 48 is also divisible by 4. But 16 is bigger, so we're going to pick 16. Does that make sense, guys? Because that's our larger perfect square. So, guys, what is the perfect square right here? What is the square root of 16? 4. So that becomes negative 6 times 4. And then we are left over with our little radical 3. So that's negative 24 radical 3 is our final answer right there. And what I like to do is I like to check myself. 2 square root of 6 times negative 3 square root of 8 and negative 24 square root of 3. Whew! We have the exact same weird decimal, so we know that we're correct. Does that track? Yes, no, maybe so? All right. Guys, I'm going to do 2 more problems, and then, y'all, I am actually going to skip the last page. I'm just not going to do it. Y'all feel good about that? All right, cool. So we're going to do 2 more problems, and y'all get to do your homework. So I will, guys, that means I am going to have to go in there and take some assignments or take some problems off your homework. Okay? So don't be faster than me. All right, so negative 3 times the square root of 12 times 2 square root of 6. So, guys, when we're multiplying, what do? Outside by outside, inside by inside, right? So negative 3 times 2, once again, gives me negative 6. 12 times 6, y'all, math facts. 12 times 6? 72, yay. I know, you got to go back and learn them. So negative 6 times 72. Guys, what is a good perfect square factor for 72? Oh, I forgot my rule. Okay, it can work for 9. Are there any others? All right, it's not nice and perfect. All right, so 72 is divisible by 9, but Bella, this is one good hint. Does 8 have any perfect square factors? So if 8 has a perfect square factor, then that means you can pick a larger one. Does that make sense? So let's think here, guys. So 72, what else can it be divisible by that's a perfect square, y'all? Let's try 36. Hey, that's our winner. Does that make sense? So we're going to pick 36 over 9, so I don't have to do more work. So what we're going to do is we're going to say 36 times 2. And then we still have our little negative 6 on the outside. So guys, what's the square root of 36? 6. And then we have our square root of 2 left behind. Negative 6 times 6 gives me negative 36 square root of 2. Okay, y'all? So negative 36 times the square root of 2. I'm going to check myself here. Negative 36 times square root of 2. And would you look at that? Those weird looking decimals are exactly the same, so I know I'm correct. Do y'all see how you can kind of check your answers there? It's kind of cool. Okay? So you can see it there. All right. So guys, all right, so we're going to do one more, and then we're going to be done. All right? And then y'all have a chance to work on your homework. So guys, we're going to do 3 times 2 to the square root of 56. So guys, we do outside by outside. Well, that's going to be 3 times 2. I don't know why I pick 6 every time, but whatever. So 3 times 2 is 6. And then guys, is there another radical here? There's only one radical. So we just bring it down. Square root of 56. Does that make sense, guys? There's nothing to multiply it by, so you just got to bring it down. Okay? Oh, man, once again, I forgot to check. 3 times 2 times the square root of 56. Nope, that does not give me a nice whole number. So that's 6 times the square root of 56. So now, guys, what we are going to do is we have to figure out what's a perfect square that goes into 56. Well, guys, I'm going to start with this and say 56 divided by, not 36, that's 1.5. It's got to be less than half of it, right? So let's do 56. What'd you say? 25. Nope, not a whole number. Let's try 16. Ah, we're getting closer. There we go, 14. All right. So 56 divided by 4 gives us 14. And guys, does 14 have any perfect squares? No. So that one's a good one. So then, guys, the square root of 4 is 2. So 6 times 2 times the square root of 14 gives me 12 times the square root of 14. And guys, I'm going to go ahead and type this in from the beginning here. 3 times 2 the square root of 56 is the same thing, I hope, as 12 square root of 14. Yes, it is. It's the same weird looking nasty decimals. Do y'all feel pretty good about this? Yes, no, maybe so? All right. So guys, a couple square roots that I feel like I think should be simplified but can't be simplified are 10. You can't simplify 10. It feels wrong, though, because 10 is like, it's an even number. You should be able to do it. But, guys, 10 is not divisible by 4. It's not divisible by 9. It's only divisible by 1, right? And 2 is not a perfect square. Another one is 30. Because it's 2, 15, 5, and 6. None of those are perfect squares. So those are all the factors of 30. So none of those are perfect squares. So those two, I always feel like you should be able to simplify them, but you can't. So guys, sometimes you will get some that can't be simplified. Like square root of 30 is just the square root of 30. You can't simplify it. Okay? Does this help a little bit, guys, as you guys are going? Okay, so what I want y'all to do right now is you guys can go ahead and y'all can get out your Chromebooks and work on your homework. We got 22 minutes left in class.